Okay, good morning, class. Let's continue from yesterday. So, yesterday we talked about concepts, constructs, and started on variables. And today we will elaborate on the topic of variables and to have a really deep understanding of what they are and what they can do, and more importantly, what we can do about them. At the same time, before we make an official start, let me know if you have any questions or suggestions about the clips that I made for the past two lectures. Um, do you like them? Do you dislike them? What do you think I can do better about them? Let me know. And of course, let me know if you have any questions about the content, um, or if you would like to seek for clarifications. You know how to reach me. Okay, let's continue. So, a quick review, just in case, we forget about what we talked about last time concepts. Concepts are words, right, are terms that summarizes the commonalities of a class of phenomena, right? We say dogs are four-legged animals that bark. So four legs and barking are the common features of all dogs that we know. So dogs or dog is a concept. Constructs, they're also concepts, right? Concept is a broader sort of notion, whereas concepts is a subclass of concepts, right? So we have concepts here at the higher level of this hierarchy of no ideas, and then to move down the hierarchy, we have constructs, right? So we know that constructs are a type of concept because constructs are concepts specifically designed or invented for scientific purposes. Right? All right. So lastly, so for example, natural selection is the example that we used yesterday. It's not a concept or a term that we used that often in daily life. Rather, we mostly use it when we talk about biology um, or nowadays psychology. So natural selection is a specific type of concept that we call constructs. Lastly, variables. So variables can be a concept. And of course, it can also be a construct, right? We can say the number of tables, right? The number of tables is a variable, right? Of course, I mean, you know, households that differ in the number of tables they have, or income, right? Income is definitely a concept. It's not necessarily a construct because we do talk about income every day. Um, so income is also a variable, right? People they differ in how much they make, and of course each individual they also make different amount of money depending on their stages in their career. Uh, and of course, we talk about, for example, power is is a construct, right? It's a construct that we use very often in psychology and in sociology. And of course, we talked about this yesterday, right? Power can take on different values from not powerful at all to very powerful, right? So by using the scale, and once we start assigning numbers, assigning values to a construct, or once we start assigning values to a concept, we're turning constructs or concepts, or just loosely, we're turning concepts into variables. Okay? All right. And yesterday we are here talking about this formidability hypothesis, using it as an example illustrating um, the function of variables. So we say, we can turn power, aggressiveness, these two concepts or these two constructs into variables by assigning values to them. We can say someone is very powerful and someone is very aggressive, right? Versus someone is not powerful and someone is that person is not aggressive or you know not prone to anger at all, right? So once we're talking about different values of of concepts, we're speaking in the language of variables. So you know once we start talking about variables, then we can start to reformulate this hypothesis in a very concrete fashion, right? So previously we say that formidability hypothesis predicts that power will predict one's aggressiveness. So it's still a little bit abstract, but once we replace other terms in that hypothesis with variables, strong, stronger, right? That this word itself implies change from strong to stronger, more prone to anger relative to less prone to anger, right? So immediately we're talking about this, or we're discussing this hypothesis in terms of variables, and that really makes everything more concrete. And it's always a sort of a good practice in science that the more concrete we can get to a question, the better chance we have to answer it um, correctly, right? Okay, so let's say now this is our hypothesis, the hypothesis that we'll be working with. My question for you at this point will be, assuming assuming that this hypothesis is correct, how could we visualize this hypothesis? Visualization is a very, very important technique in conducting science, not just social science, but all kinds of branches of sciences. Because visualization, visualizing hypotheses and visualizing data as well, as we'll see in a minute, will greatly facilitate our understanding of what we have. So, an important skill that I hope that all of us can master or start to learn is how we can draw out, using bar charts, using lines to plot the statement. Okay? All right, so I'll give you a little bit of hint since it's probably our first time to plot any hypothesis in our life. So, first of all, recall that we have two variables. One variable is a person's physical strength, right, representing how powerful the person is. And then we have a second variable that is how prone, how easy they will become angry. So that will be our second variable. Because we have two variables, we'll place them on this coordinate, right, that we should be very familiar with. That's, I think, from, high school math or junior high. I don't know. But we should not be very foreign to this idea, right? So by placing these two variables, one at each axis, right? This is an axis. This is a second axis. Usually we say this is the this is the y-axis, and this is the x-axis, right? X-axis. Um, and usually, there's sort of convention that says if our hypothesis says A predicts, well, X predicts Y, or A predicts B, right? Or, X X is correlated with Y, or A correlates with B. We usually, let me emphasize, we usually, it's not a must, but we usually put X or A, the variable, the variable that we mentioned first, onto the x-axis, and we place the variable that we mentioned the second on the y-axis. There's really no reason why we should do this, and sometimes you will see people do exactly the opposite. So that's why I said it is a convention, right? Convention is something that we all agree upon, but there's no real reason why we should do this. So for the purpose of the class, let's follow this convention, right? We place the variable that we mentioned the first at the x-axis, and we place the variable that we mentioned the second on the y-axis. Okay, so now we have these two variables at the appropriate places on this coordinate. Now our question is, how do we visualize their relationship, right? We say that physical strength, that's our x. Well, if someone is stronger, that means if, we designate that this end of this axis denotes that someone is weak, right? This is weak. And this strong, right? At the same time, this is not angry. Well, my apology for my handwriting here. And this is very angry. Okay, so now we have designated the direction of our scales, right? So for both scales, it's, moving from small to large, from small to large, or from negative to positive. Well, however you describe it, right? So we know that if a value moves from this end of the scale to this end of the scale, that means, a person gets stronger and stronger. Similarly, if a value moves from this end of the continuum to this end of the continuum, that means a person becomes angrier and angrier. Okay? So now our hypothesis is that if a person is stronger, that person will be more prone to anger. If that's our hypothesis, what should we draw here so that this graph can represent or can visualize our hypothesis? Okay, I'll give you 2 seconds to think about it. 1 and 2. So many of you may have guessed we use a straight line, a upward tilting line, to represent this hypothesis, right? This line is shooting in this direction. Therefore, it means if we, randomly pick a point. Let's say randomly pick 2 points on this scale. Say this point 1 and this point 2, right? And we shall be able to immediately see why this line makes sense, because this line represents someone is about this much strong and about this much prone to anger. Whereas this point represents someone who is this much strong and this much prone to anger. So this is person 1, this person 2, and we can immediately see that if we move from point 1 to point 2, that suggests as people become stronger, right? As people become stronger, they will at the same time become more prone to anger. That's exactly what the formidability hypothesis says, right? You can say, well, Andrew, that's because you're designating that we move in this direction. How about we move in this direction? Will our conclusion still be the same? Well, that's a good question. So let's figure it out, right? So let's first of all write out the exact words of our hypothesis. Stronger, physicality leads to, um, more anger. So we just said if we move from this direction to this direction, right? So if we sort of imagine that this line starts from here and extends itself to here, then of course this line corresponds to our formidability hypothesis. But a question is, well, what if the line actually starts from here and it goes down to this point? In other words, what if it goes in the opposite direction? Would this line still represent this hypothesis? I think that's a very good question. And let's see whether this makes sense or not. The short answer is, no matter how in which direction you go, you can go in this direction, you can go in this direction. The answer is, it doesn't matter. It doesn't change how we interpret this line. This line, as it is, regardless which direction you go, will still represent this hypothesis, and here's why. Because when we say stronger physicality leads to, more anger, it's the same way to say, rephrase this sentence to say, if you are weaker, you will experience less anger. And these two hypotheses are exactly the same. So if that's the case, and it is the case, then we can say, well, if we go from this direction, right, in this direction, then essentially we're moving from point 2 or individual 2 to individual 1. And we're saying, well, as people become weaker, right, we're moving in this direction, they will at the same time be less prone to anger. So you see, when we interpret this line in this direction, it will correspond to this hypothesis. And if we interpret this line in the upward direction, we're talking about this hypothesis. And this hypothesis and this hypothesis are equivalent. So that means as long as the line is upward tilting, then it doesn't matter in which direction, upward or downward, we interpret this line represents the same hypothesis. Okay? Does that make sense? I hope it does. So um, that's probably the most easy visualization we have so far. That is, we use a straight line to represent a correlation or association between two variables. Okay, let me repeat that. We use a straight line to represent the correlation or association between these two variables. Okay, this is really the foundation of all visualization of data, or I should say the visualization of correlations. Okay, and later on we'll be talking about more complicated but more interesting, relationships among three variables. Once we have that, how do we visualize their relationships? Okay, but now let's start with this one, right? I hope we understand why this line makes sense. Good.